Hey all, it's Andrew Couch here, and this Tidy Tuesday video, we're actually not going to analyze this week's dataset. We actually already did analyze this dataset, which is the Palmer Penguins dataset, where we actually created a dashboard. Instead, I think it'd be interesting to kind of do a shorter video and kind of go over the GGanimate package, which is an extension to the ggplot2 package, which basically creates animated charts. So Thomas, what's his name? Thomas Peterson created this package. It's a really cool package, and it's actually a pretty simple one. I actually don't know. I don't really use a lot of animated charts in my day-to-day analyses. However, I think animated charts are really good for a lot of like data journalism style stuff. I think they can add a lot of impact to your storytelling with data. However, for actual analysis, I'm not sure how much value it adds to some like data science related projects. But one of the most classic examples of animated charts to use as a storytelling device is it's this famous chart where it shows like the progression of life expectancy to GDP per capita for each continent. I believe there's a really popular like a TED talk on it. But I think it'd be interesting to kind of look at this ProPublica data set, which is about NYPD civilian complaints against New York City police officers. I actually requested the data set and I have it already. So we're just going to open it up into our files. So I'm going to go here, go to my Tidy Tuesday repo and then set that as my working directory. I'm going to open up a R markdown file. And I'm going to call this Tidy Tuesday animated animated charts. Okay, cool. I'm going to pop this up. And we're gonna do that. So let's actually load in the tidyverse, the GGanimate package, and we're also gonna load up the GIF-ski, which is like the rendering engine to it. And finally, I'm gonna do the read.csv, police allegations.csv. Okay, so if we actually look at our DF, we can see that each row represents one complaint against one police officer. So unique MOS ID is the police officer's name. If I actually go on to my Tidy Tuesday folder, we have a kind of a data explanation, so we can kind of refer to that too. Oops. So we have the layout, which is like which like a little data dictionary. We have some abbreviations of the explanations, command abbreviations, FADO, which is kind of like the what the officers are being accused of, and we also have dispositions, which to me I think the disposition is a pretty important thing. So for example, if we look at substantiated, it means that the alleged conduct violated the rules. Exonerated means the alleged conduct occurred but did not violate the rules. And then unsubstantiated means it was investigated but could not conclude that they broke the rules. So when I look at this, I think really substantiated and exonerated are basically pretty bad because we don't want police officers to have any truth in their allegations of misconduct. Unsubstantiated is the best case scenario. Okay, so let's do this. One thing that I thought would be interesting is just kind of look at the actual time series of the actual allegations. So what we can do is we can just do a select, and we can do let's say year received. So it was a year received. And what else do we want? How about we do FADO type. And what else should we do? So we have like the allegation or FADO type. And then let's do the actual outcome, or let's say maybe board disposition. Since that way we can look at the substantiated, unsubstantiated, and exonerated. Okay, so we have that. I think I'm gonna do just a slight renaming. So FADO type, we'll just say the allegation, and board disposition is the result. Okay, cool. So one thing that I think would be good is to change these things into just like kind of like the results of it, right? So I'm going to do a mutate and say result equals, and since I want to do a bunch of if statements to basically change, like substantiated will mean this, unsubstantiated will mean this, exonerated means this. So I'm just going to use a case when statement, which is a very useful way to do a multiple if else statements in a digestible manner. So what we're going to do is we're going to say str detect result, and the pattern is we'll say substantiated. I'm just going to copy this. Substantiated. If that's true, it means that there technically was a violation. So we'll say violation. Additionally, we'll also do another one and say result, and then we'll say exonerated. And if we look at our data table, right, we can see that exonerated means the alleged conduct occurred but did not violate. So that means what the allegation did happen, but did not violate any of the rules. So we're going to still call that a violation, right? And then we can also do it. And then finally, we can say true, or else we'll say no violation, right? So we have that changed. Okay. So what else can we do? We can do like a basic count of like the allegations, okay, or the phenotypes. So we can see the count of it. So let's say group by year received, and we'll say count allegation by result, right? Then we'll say an ungroup. So what this shows us is like, okay, so if we do a little arrange by year received, allegation, and result, we can see that. So there were 3 abuse of authority allegations that resulted in no violation, right? So we can see kind of the result and the total amount of accusations made. Okay. So what we want to do now is actually make a plot of this. So we can say like, okay, we'll do a GG plot. Received, let's say y equals n, and we'll say color equals, I don't know, allegation plus geom line, and maybe do a facet wrap, and we'll just compare the violations and no violations, right? So we'll say result, let's say scales equals free y. Year received, let's see your year. Okay, so we have that. Maybe we'll throw in the theme legend dot position equals top. Right, so we have the allegation. We can see how no violations have been increasing, and also violations have been increasing for all of it. Additionally, we can see how 2020 dips. That's because probably not all of 2020 has been fully completed. Okay, so that's pretty interesting, right? So how do we make this into an actual, I guess, animated chart? So what we just have to do is we can do this, and we can add a transition. So if we go to our GGanimate package, we can see that most of it just relies on transition states. So it's just extending your plot and adding transitions and specifying how you want to make those transitions. So in this case, we actually want to transition by year because I want to reveal like the result of these plots. Okay, so I'm going to do this. I'm going to say transition, transition, reveal. In this case, we'll say year received, right? Because we kind of want to go throughout the year and see like, oh, wow, there's a huge increase on just overall allegations. And we can see how both violations and no violations have kind of increased together. Okay, so we have year received, and that's basically it. So let's make this into a violation TS, right? So I'm actually going to paste this right here so we can kind of have this other thing going on. Okay, and what's DF review? Okay, so once we have our violation TS, what we need to do now is just use the animate function and give it the violation TS, and we can say the renderer. In this case, I think the default is this type of renderer. However, you can also convert this into, instead of rendering it as a GIF, you can render it as like an MP4. Okay, so it's gonna start animating the chart, and we can see it kind of continuing like that. Okay, and now you can see the frames are loading up, and now it says final encoding done. And you may be wondering, like, where is our animated chart? Well, if we look over here, we can see it moving. Right, you can see how it's being shown, the time series, and we can see it increasing, and boom. Right, pretty cool chart. We can also add just some cool little things like what's here? We can also add a a GM point. So if we do GM point, it'll show us the chart with a little point that'll kind of follow along. And as you can see, all these charts do take a long time to actually develop or render out. I'm not sure what's the best way to make it to increase the rendering, but it's still pretty fun and it's pretty easy to implement. So you can see how it's kind of like, you can see the leading line that's a little point, which is really nice to see. Cool. So we can also do more like, we can also kind of extend it to other things. So instead of doing transition reveal, what if we want to do like more of a time series? So if we go here, maybe they'll show it. So they show different transition states. Is there a transition time example? Okay, not really. But what we can do now is kind of look at some other stuff. So what if we want to look at the each year's each year's result of the allegations, right? So let's do that. So let's do df. Let's say select board disposition and year received. Cool. I'm actually going to add the same thing that we added right here. Which actually I might just, you know what, I'm gonna actually assign it, just that. So I'm gonna do that and say df, boom, df mutate. Let's see a result. Oh, it's because result. It's not result. It's was it board disposition. We'll say boom like that. Okay, so now we have a result. So now what we can do is select result and year received. Right? And what another thing that I want to do is let's just count year received and result. Cool. And then we can do maybe like a ggplot, x equals result, y equals n, fill equals result, let's gm column. Cool. Yeah, let's do that. And then we can just do a let's see here. Let's say we don't really need a legend, so let's say theme legend dot position equals none. Okay. Finally, we can add a transition. So in this time, in this case, I want to just do a time series, which this plot right here, violation, was actually doing that beforehand. It's basically showing a time series. However, it's not showing the difference in time, where it's not making the new chart each different time. It's just kind of doing a reveal through the time. I'll kind of show you it right now. It looks a little bit different. In this case, we want to look at each year's violation and no violation change on a bar chart. Okay, so let's do that. So transition time, and we'll say year received. Oops, year received. Okay, and we'll say disposition result. then what we can do now is just do a animate disposition result renderer GIF ski renderer. And let's see what it looks like. Let's see how it changes. Okay, so you can see how it's kind of increasing, but we kind of have a huge problem with this. For one, we can see how, violations, both no violation and violation is increasing, but we kind of don't know which year it is. Luckily, GGanimate actually comes with some functions to put into your label. So if we say labs or labels, and we can say title, and we'll say year, and then what we can do now is just use the glue syntax, which is basically like a pseudo variable. So in this case, each little frame or each plot represents one frame. And so since we're using transition time, I'm going to say frame time. Okay, so let's just send this. Let's just render it again. Okay, and now we can see how the year is changing. And how overall, like we can see how, like maybe in 2014, 2016, there's more violations than no violations from the result. Great. So when I was also looking at this data, we found out that there was actually some precinct data, because for each officer, an officer is serving a precinct. So I thought it'd be interesting to kind of look at it by precinct, right? So let's do that. Let's say select precinct, the officer. In this case, the best way to select the officer, I think, is the unique MLS ID, which is kind of like the identifier for like first name, last name, command now, and stuff like that. And let's do the fatal type. Okay. And what I want to kind of look at is I want to look at kind of the distribution for each precinct's officer complaints. And what I mean by that is like, okay, for each precinct, what is the average amount of complaints per officer? Right, that'd be kind of interesting. We could see like, oh, maybe one precinct has way more complaints than the other precincts. And what we can do now is we can just say like group by precinct, and we can say count unique most ID for each officer. We want to count how many allegations they have for each fatal type. Okay, so in this case, in precinct 0, this officer had one accusation of abusive authority. Okay, so now what we can do is we can just do ungroup, and what we can do is just a simple ggplot where we'll say like, x equals n, fill equals fatal type plus gm column. GM what am I stop? GM histogram. Right? And we can see how most officers are only getting for each officer in a precinct, most allegations are only once. It's usually just a one-time deal. They only have one complaint against them throughout, I guess, this decade, these like years of NYPD police reports, which is kind of a good thing. In a perfect sense, we would have 0, but obviously this is just only showing ones who have allegations. But we can see that. Okay. So now we have this. What I kind of want to do is, let's say theme legend dot position equals top. So we have that, and I'm kind of interested. We could do a facet wrap too. We could say like facet wrap by fatal type scales equals free y, right? Maybe do that. That'd be kind of interesting to see that. And then maybe we could just say none, and we can see the difference in distributions for all 4 of them. Okay, maybe I'll add a plus scale x log 10. See what that looks like. Sure, that looks kind of interesting. Maybe even like a scale x square root, right? Okay, maybe, I don't know. We'll figure it out. Okay, now I'm gonna do a transition, And since what I want to do is I want to go by a precinct, we can just say the precinct isn't necessarily an event because it's kind of like almost a categorical variable. So instead, what we're going to do is transition states. So it's just going to cycle through each precinct and make a new plot. Okay. So in this case, we're going to say precinct. And what we can do now is we can add in our labs. So labs, and we'll say title equals precinct, and then we can do our thing. And for our transition states, it actually kind of goes in and out. So it doesn't just kind of do a click, click, click of like a discrete variable. It actually kind of does like a continuous style. So what we're going to say is we're going to do a closest state. So one thing that I get confused about a lot is like the actual glue syntax. So in this case, we're just doing closest state. Nothing too crazy. What else can we put into this plot? Oh yeah, for our transition states, we can actually customize the transitional length. Oops, come on. The transition length and the state length. So what I was seeing is he for most of the examples, they actually just say like transition length is 2, state length is 1, just so it's a little bit smoother. You can also change it where each precinct is shown for a longer time and it transitions faster. It's kind of up to the visualization and depending how many states you're going to go through. So I'm going to make this plot first. Precinct distribution. Right, cool. And then let's do a animate and say precinct distribution renderer is GIFSKI renderer. Cool. Let's have it run. And it's going to take a while because it's essentially making a lot of images of the plots and then kind of like doing a flipbook of it. It's going through each frame and plotting it out. Okay. And you can see how the precincts are changing. They're showing it out. But one thing that I see here, right, is it's kind of choppy. It's not as pretty as say, as this one, right? Where it's kind of doing a nice transition. It's not as clunky, So what we can actually do now is we can add in enter fade and exit shrink. So that's what I'm going to do. So I'm going to say plus enter fade plus exit shrink. Okay. And then I do control shift enter and I'll animate it again. So let's see it kind of go on. I actually really like this plot. I think it's really interesting to just see how you can see how these precincts obviously have an effect on just the amount of complaints. And that could just mean there's more population, there might be more crimes. There's a lot of other factors into it, but it's just interesting to look at how not all precincts are created equal. Additionally, I think it'd be interesting to see, what discrepancies do some precincts have. Okay. So I guess, yeah, okay. So it's kind of going through. I guess the bar chart really doesn't do well with that fade in and the shrink. We might have to actually increase the transition length and stuff like that. But I think we should go on to one last plot. This plot I found to be pretty interesting when I was looking at the data. So for example, we also have the rank of the officer during the incident. So I think that'd be kind of interesting to look at. So let's do that. So let's say rank of the incident, maybe year received. And then let's do and then the result. Okay. So what I want to see is our say if we look at our rankings, so let's just say select rank of the incident distinct. Well, I'm curious I wonder if say police officers are more likely to have more are more likely to be to have allegations sent to them that are true, opposed to say a captain or a lieutenant, right? So let's see if there's any type of relationship that we can look at. So let's do that. And what we can do is just do a simple count. So group by year, year received, and say count rank incident and the result. So for each year, we're gonna count, for every year, we're gonna count each rank's violations or result of violations, right? So we're gonna do a ungroup, arrange by say year received, rank, incident, and result, right? So we can see like, okay, 1985, how many violations, how many non-violations were came out of it. Okay. Additionally, I kind of want to look at the total results, total allegations, right? Maybe we want to control for that. So we can also say mutate and say total allegations equals sum of n, right? So total allegations, sum of n. And then we can do a ungroup and do that. So once we have that, what else can we do? Let's compare. Let's see here. Let's compare the violations. Let's compare the violations to no violations for each incident and go through it by year. But what I want to do is kind of control for the total allegations, right? So let's see how we're going to do this. I actually won't do that. So then I'll say mutate, and I'll say mutate n equals n divided by total allegations. Right, so now it's more normalized. And then what we can do is then ungroup it. Great. Actually, maybe, we'll say, I got an idea. We'll say n equals n divided by sum n, or we'll say proportion, or we'll say prop, or p of p results. There you go. So that way it's a little bit cleaner. And then we'll say count, and then we'll say name equals. No, that's fine. Sorry about that. Okay. So if I wanted to compare the results, the no violation and violations for each officer, given their P results, I'm going to do a pivot wider. So I'm going to say pivot wider, names from is result, and values from equals P results. Right? Okay. Ooh. Actually, I got an idea. Maybe I can't use that then. You can see how these things, I want these to be on the same row. So what I'm going to do is I'm going to deselect n. So select minus n. Select minus n, and now we'll do that. There we go. Okay. Interesting. Actually, I want to do some validation right now. So, okay, we have those. Okay. So violations, no violations, etc. Okay. What I'm confused about right now is, let me see if I'm grouped by. Oh, okay. I need to also group by, was it rank of the incident? I think. There we go. Yep, there we go. Okay. And then we can do a select minus n. And there we go. Okay. Sorry about that. I saw that one of the proportions weren't lining up. Okay. So we can see how there's some NAs, and we can say, was it values fill equals 0, and it'll fill it up with 0. And now what we can do is ggplot AES x equals no violation, y equals violation, color equals rank of the incident, and maybe just do it geom point. Actually, maybe I'm going to flip it up. I'm going to flip it. So violation, no violation, violation. Okay, and then we'll do plus geom point plus, what is it, scale x reverse. There we go. 1, there we go. Plus scale y reverse. I think that's, is that what we want? No, we don't. Okay. You know, when I'm looking at this plot, I think it might be easier to just have it on a frequency basis. So just set. However, we can actually look at it. So we can just do a transition. In this case, I want to do it just by time, right? So I'm going to transition time. In this case, I'll say year received plus, I don't know, what is it, labs. And then we'll say title equals year frame time. Okay, and we'll say rank allegations. And we'll just look at this plot. So we'll say animate, rank allegations. Was it renderer, gift ski, renderer. Okay. Okay. Yep. I don't like to do this. Okay. So I'm going to actually do that instead. Okay. So instead of doing the proportion, I'm actually going to do this. So we'll say n, and let's see what it looks like. Right. So we have violation, no violations. I think this will look much better. So let's see what that looks like. See how it's kind of like it's going off back and forth because I kind of normalized it, and honestly, it doesn't look good in this type of line. It might be better to be actually on a horizontal line, but I think just having the frequency approach is a little bit better. So we can see how it's moving. One thing that I think would be good is that if we add in geom AB line and say slope equals 1, intercept equals 0. That way we can kind of put in a plot where basically the slope will be right here, and we want the points to be below the line, because that means that the majority of their allegations resulted in no violation. So I'm gonna do that. So say subtitle equals points below the line means majority of allegations were false. Points above the line means majority of allegations were true. Okay, I think that's a smart idea. And then what we also can do is we can say a size equals like 12. And I'm gonna put this thing under there just so the points can be above the line. Okay, let's see what that looks like. And you can see how police are kind of just rising in violations, and a lot of them are going above the line. It's pretty cool. It's a little sad, but it's pretty interesting. So one thing that I want to do is I want to maybe change it a little bit. So I'll say color equals, let's say color equals, we'll just remove the color title. In addition, what we can do is we kind of add in, see how these things are moving, but we kind of don't know where its previous location is. It's just kind of running everywhere. We can also add in this thing called shadow wake. So shadow wake length equals, we'll say 0.1 alpha equals false. And this will just add kind of like a reference little tail. So let's run this again and we'll call it a day. Oops. And I'm going to actually show you what it's creating for the Tidy Tuesday thing. Sometimes when you render it, it'll kind of put it into a temporary folder of just like images, and you kind of have to be careful about it. Okay, so now what we can see here is that, see how this, you can see a little tail or kind of residual patterns. You can see where it's kind of going for its trajectories. That can be pretty useful. So you see points below the line means majority of, means majority of alligator fault. Yeah, there you go. So that was basically it. I know this is kind of a quick, simple video, but I thought it'd be kind of fun to kind of go over these cool little animated charts. I know they're really popular on Reddit, and they're pretty easy to make and extend the ggplot universe. I think for future videos, I think I might work on more extensions to ggplot 2 and kind of focus a lot on data visualizations. So with that being said, I'll see you guys next week and tidy on.